Alright, we're continuing day 4 notes talking about graphing in vertex form and converting between standard and vertex form. So I'm back at the top of page 2 of your notes for today, and I wanted to go over a couple of things before we moved on. So my graph here has an A value of positive 2. So since A is 2, my graph is going to be open up. When my graph is open up, my vertex right here is called a minimum because it is at the bottom of your parabola. On my second graph that we did today, we have an A value that is, that is negative. So when my A value is negative, that means my graph is open down. When you have a graph that's open down, that means that your vertex is a maximum. When your vertex is a maximum, that means that it's at the top of your parabola, like you see right there. And finally, for my last equation that we graphed, we don't have an A value that is listed. But if you don't have an A value that's listed, that A value is going to be 1. Since A is 1, my graph is going to be open up, and we will have a minimum. So that is all for the first and second page of notes. Now we can go on to our third page to where we're talking about converting from vertex form to standard form. Make a little bit more room for us to work. There we go. Alright, so how are we going to change our function, which is stated here, to standard form? There's 3 steps that I like to follow when we are doing this. My first step is to box. Some people call it FOIL, but I prefer to use the box method. And that's where I take my x plus 1 squared and I deal with that. So I'm going to draw my box, which is a 2 by 2 box in this case. I'm going to do x plus 1 on the top and x plus 1 on the side. I'm going to fill in my box using multiplication. So I have x squared, x, and 1. Now I'm going to rewrite this outside of the box, but I'm going to put it back into my equation as well. So I want you to understand that we did not touch this 2 on the outside of the parentheses. The only thing that we touched was this x plus 1 squared. So in place of my x plus 1 squared, I'm going to put this back in its place. I'm going to have x squared plus 2x plus 1, and then I didn't touch that negative 2, so it's just going to come on down. You might be wondering where I got the 2x from. Well, when I combine all the terms of my box, my x and x combine together with addition to give me 2x. Alright, my next step to changing to standard form, step 2, is going to be distribute. And I'm going to distribute that 2 to all the terms in the parentheses. It's going to give me 2x squared plus 4x plus 2. And I didn't touch that minus 2 on the outside, so I'm just going to bring it down and rewrite it. My last step is going to be combine like terms. So I'm going to combine my 2 like terms together, which is positive 2 and negative 2. 2x squared and 4x do not have like terms in this statement. So when I rewrite it, I'm going to have 2x squared plus 4x. And that's going to be my final answer, because that positive 2 and negative 2 added together to be 0, and we don't write plus 0 in our final answer. So here you go. So our 3 steps for converting from vertex to standard form is box, distribute, combine like terms. Let's go ahead and do that again for our next problem. So I'm going to write the steps on the left. Step 1 is box. This pen's really big. Hold on. Step 2 is distribute. And step 3 is combine like terms. So I'm going to draw my box over here this time. It's going to be a 2 by 2 box, and we're dealing with this x minus 1 squared in the box. So we have x minus 1 on the top and x minus 1 on the side. X times x is x squared. X times negative 1 is negative 1x, or just negative x. Same thing here. X times negative 1 is negative x. And negative 1 times negative 1 is positive 1. Now I'm going to rewrite my problem, only subbing in for this x minus 1 squared. We didn't touch this negative 3 on the outside, and we're going to change the x minus 1 squared to what came from the box. So it's going to be x squared minus 2x plus 1, and then we're going to keep our plus 2 on the outside because we did not use it. And remember that negative 2x came from combining the negative x plus a negative x. So negative x plus negative x is negative 2x. Next, I'm going to distribute. So I'm going to distribute that 3 to every term in my parentheses. I get negative 3x squared plus 6x minus 3. I'm just going to bring down that plus 2 at the end because we have not touched it yet. And my last step, I'm going to combine like terms. My only 2 like terms are my negative 3 and positive 2. 3x squared and 6x do not have like terms in this equation. So my final answer is negative 3x squared plus 6x minus 1. The next thing that we need to talk about is converting from standard form back to vertex form. And remember when we had our vertex form, that setup looks like this. Y equals a x minus h squared plus k. So when we're converting from standard back to vertex, we need to find 3 things. We need to find our a value, our h value, and our k value. And remember that hk is our vertex. So my first step for finding a is just to look at my original problem that's in standard form and find that a value. Remember, our a value goes with our squared term, and it's the coefficient of our squared term. Our squared term's right here, and we don't have a written coefficient in front of our squared term. If there's nothing there, and we're multiplying things together like we are with the squared term, that value is 1. So my a value is going to be 1. Next, I'm going to find my h value. Remember in our previous video, we talked about how h can be found as the x value of the vertex, and also with the x value of the vertex, that's also our axis of symmetry. And we've learned prior in this unit that we can find our AOS / our H value by using the formula x equals negative b over 2a. So we can plug in our b value and our a value into this equation to get our h. So we have negative parentheses, my b value of 6 over 2 times a, and a in this case is 1. So I have negative 6 over 2, which gives me negative 3. So negative 3 is going to be our h value. And to find our k value, you're going to be relieved, it's pretty simple. We can just grab our calculator, go to table, and write in our standard form equation, which is x squared plus 6x plus 4. And to find that k value, we would want to go to our x value of negative 3, and it will give me my k value of negative 5. So now I have everything that I need to write my equation in vertex form. So remember, my original vertex form is y equals a x minus h squared plus k. And I'm only going to plug in a, h, and k. So my new equation will look like y equals a, which is 1, x minus h plus my k. My k in this case is negative 5. And you see after I wrote this I have a negative, negative, and a plus negative. So I'm going to go back in and clean this up a little bit. 1 x minus a negative is the same thing as plus a positive, so it's x plus 3 squared, and then plus a negative is the same thing as minus, so we'll subtract that 5. And that green at the very bottom is going to be our final answer. So we have just converted an equation from standard form to vertex form. Now we want to do it again. Remember, first step is to find our a value. In this case, our a value is 1. We'll find our h value by using our AOS formula. So x is equal to negative b over 2a. So we have negative times negative 8 over 2 times 1. Negative times negative 8 is positive 8. 2 times 1 is 2. 8 divided by 2 will give me 4. So my h value will be 4. And to find k, remember all we have to do is plug it into our calculator. So table, x squared minus 8x plus 12. My h value is positive 4. We'll type that in, and it will take us right to my k value, which is negative 4. So now all I need to do is rewrite my vertex form and plug it in. So y equals a x minus h squared plus k. So I plug in my a value of 1, x minus h, which is 4, squared, plus my k value of negative 4. I'm going to clean it up just a little bit because I have a plus a negative number. I'm going to change that to y equals 1, x minus 4 squared, and then plus a negative changes to negative 4. And that will be my final answer. If you want to go ahead and try the next problem on your own to see if you can rewrite it in vertex form. Alright, here's our final problem. We found that a was negative 2, h is negative 3, and k is 2. We plugged it into our vertex formula and came out with our final answer.